Next, second one, if u is function of x and k is constant, then d by dx of ku, which is equals to k into du by dx, right? So let y equals to ku, take it as equation 1, as x changes to x plus delta x, that is small increment or a small change we can say. Suppose u and y changes to u plus delta u and y plus delta y respectively, right? So hence y plus delta y, which is equals to k u plus delta u, take it as equation 2. So subtracting 1 from 2, one from 2, we get delta y, which is equals to k u plus delta u minus of ku. So here delta y, which is equals to plus ku minus ku get cancelled, only k delta u remains. So now limit delta x tends to 0, delta y by delta x, which is equals to limit delta x tends to 0, k delta u by delta x. So after applying limit, what we get? Dy by dx, which is equals to k outside the limit delta x tends to 0, delta u by delta x, which is equals to k times of du by dx. So which is nothing but thus the derivative of function, what we can get the conclusion, thus derivative of function multiplied by a constant is constant times the derivative of a function. Derivative of a function, right? So thus the derivative of function multiplied by a constant is a constant times the derivative of function. So let's see, for example, for example, d by dx of 4x cube, which is equals to 4 keep outside, d by dx of x cube, so which is equals to 4 into 3x square, that is 4 to the 12x square, so which is x to the power of n into x to the power of n minus. Similarly, second one, 2 sin x is 2 d by dx of sin x, which is equals to 2 cos x. Next, third one, d by dx of pi log x, that is 5 d by dx of log x. So that is nothing but 5 into 1 by x, which is nothing but 5 by x. So next we will see derivative of sum. Derivative of a sum, right? So let's see, if u and v are functions of x, then what we have, d by dx of u plus v, it is du by dx plus dv by dx. So let's see, let y equals to u plus of v, take it as equation 1. So as x changes to x plus delta x, suppose u, v and y changes to u plus delta u, v plus delta v and y plus delta y respectively. So therefore, just substitute here, y plus delta y equals to u plus delta u, v plus delta v, take it as equation 2. So subtracting 1 from 2, subtracting 1 from 2, we get delta y, which is equals to delta u plus delta v, dividing throughout by delta x and taking the limit as delta x tends to 0, we get limit delta x tends to 0, delta y by delta x, which is equals to limit delta x tends to 0, delta u by delta x plus delta v by delta x, so which is equals to limit delta x tends to 0, delta u by delta x plus limit delta x tends to 0, delta v by delta x. So replacing v by minus v, we get it is d by dx of u minus v is nothing but, so finally what we can write here, dy by dx, which is equals to du by dx plus dv by dx. So the next, replacing v by minus v, we get d by dx of u minus v du by dx minus dv by dx. So this can be, so this rule can be extended to a finite number of function of x if u, v, w are functions of x, then d by dx of u plus v plus w dash dash dash, which is equals to du by dx dv by dx plus dw by dx plus so on, right? For example, first one, d by dx of a cos x plus b sin x. So here d by dx of a cos x plus d by dx of b sin x, so which is equals to a outside cos x is differentiation is minus sin x plus b cos x. So here minus a sin x plus b cos x is the required solution. So next, one more example, d by dx of 2 root x 3 to the power of x 4 log x, which can be written as d by dx of 2 root x minus d by dx of 3 to the power of x plus d by dx of 4 log x. So 2 into 1 upon 2 root x minus 3 root x plus 4 into 1 by x, which is equals to 2 to get cancelled, 1 by root x minus 3 to the power of x plus 4 by x is the required solution. So with this we will conclude our today's lecture. In the next lecture we will see derivative of a product and their example, derivative of quotients and their examples, and finally we will see some examples based on all these standard forms.